Yep, number one, we have a rectangle. How do we know number one's a rectangle? Because the sides aren't even, right? It's got right angles, looks like a square, but the sides aren't even, so it has to be a rectangle. Okay, so it's a rectangle. Okay, so next thing is area. How do I find area of any rectangle? How do I find area of any rectangle? This rectangle, another rectangle, any rectangle. How do I find area? Length times width, or base times height, right? Length times width or base times height, whatever you're used to. So what would I get? What number? What is the area? 24, right? So 6 times 4. And then for area, we always use units squared. Squared. So in other words, if I wanted to paint this rectangle, if it was a wall or a side of a house or a side of a building, I would need 24 feet square to paint. That's what area is. Okay? Now perimeter. What's perimeter? What is perimeter? How is it different than area? Is it the same thing as area? Is it different than area? What is perimeter? Exactly, around, right? On the outsides. If I wanted to put a fence around this area, this was my backyard, and I wanted to put a fence around it. How much fencing would I need, right? You add up all of the sides. So we have a 6 feet here and here. We have a 4 feet here and here. So you would go 6 plus 4 plus 4, right? So that would be 12 plus 8, and we would say 20 feet. Perimeter is linear. So you don't need a squared for perimeter, okay? Because it's linear. You take your tape measure, and you just multiply it. Or sorry, you add it. Measure, add them all together, right? There's no multiplying involved, okay? All right, so that's what you did in elementary school. And then they changed it a little bit. They changed it to look like number 2 in junior high. So in 7th or 8th grade, this is what the problem looked like. You still have your rectangle, right? It's still 6 by 4, 6 feet, 4 feet, right? But how did they change it? What did they do to tweak it a little bit? How is this problem different than problem number 1? There's a square in the middle. There's a blank spot in the middle, kind of like a donut, right? It's like a rectangular donut. So now I'm finding area not of the whole thing. I'm finding area of just the shaded part. So how am I going to do that? Not the answer. I don't need the answer. We'll figure that out. But how would I do that? Not divide. You're close. How would I do it? Subtract. Yeah, I would subtract. What would I subtract? What are the 2 things I would subtract?
6 and 4.
Say it again.
6 and 4.
What with 60? What? So you're getting there. What about 6 and 4? How would I use 6 and 4? Because there's a big old blank spot. This is a blank spot. It's not like a square on top of it. It's a blank. There's nothing there. It's like a donut. So what would I do? I would subtract 2 things, right? What would I subtract? What minus what? So I'm not trying to find x. We're not trying to find x. So don't worry about x. I'm just trying to find the area. How would I find the area? Because I see some of you guys trying to figure out what x is. Don't worry about x. Leave x alone. I'm just trying to figure out how would I find the area of the shaded part. You're right. I would subtract 2 things. What would I subtract? Not 6 minus 4. It's area. Remember, it's area, right? Length times width, right? So length times width is 6 times 4, right? That's 24, right? What does that represent? What does 24 represent? The area of the whole thing. And then what am I going to minus? Not half of it, just the square in the middle, right? So what's the area of the square in the middle? How do I find area of a square? Length times width. What is the length of the square? How long is the square in the middle? How wide is it? I think you guys are trying to figure out what x is. Don't figure out what x is. Don't do that. We'll do that later. We're going to do that, but not right now. Not on this question. You guys didn't do that in junior high, right? In junior high, you just figured out as much as you could. So what is the length of the square? Well, don't try to figure out. Don't try to figure out what x is. Don't try to figure it out. What is the length? X. That's all it is. It's x. So what is the area of that square? Times. How do I find area of a square? Length times width. So what is the length? What is the width? X times x, which is? There you go, right? So that is the piece missing. That's the whole. This is the missing, right? You just subtract the whole and the missing. Do we know what x is? No. We didn't solve for it. You didn't solve for it then. You just said that's what it is. Today we're going to solve for it, and I'll show you how to do that. Okay? So that's the area of the shaded part. The whole, 24, minus the missing, x times x, x squared. Okay? So today, we're actually going to solve for those x's. We know how to already. We know how to. Okay? All right, so let's look at number 3. Let's look at number 3. Okay? So the width of a rectangle is 4 units less than the length. So we have a rectangle, but they don't give us a picture. So the first thing you're going to do, if they don't give you a picture, draw a picture. I'm telling you right now, it'll help. Make math visual. The more you can make math visual, the easier it is for yourself. Okay? Okay. So we know we have a rectangle. What do I know about the rectangle? What do I know about the rectangle?
The width is 4 units. Oh, wait, never mind.
You're right, 4 units less than the length. So whatever the length is, I got to subtract 4, right? Do I know what the length is? No. So when I don't know what something is, what do I use in math? An x or a y or a letter, right? So if we call this x, what is the width going to be? X minus 4, right? Isn't that what this means right here? Less x minus 4. Right? That's what that means, right? And the other side is x, and the other side is x minus 4, because it's a rectangle. What else do I know about the rectangle? You guys are right so far. You guys are doing good so far. What else do I know about the rectangle?
The area is 21 square units.
The area is 21 square units, right? That's also what I know. How do we come up with area? How did they come up with 21? What did they do to come up with 21? Length times base times height or length times width, right? What is the length of this guy? So I got to multiply two things, right? Multiply two things. What is the length and what is the width? X times what? That's the length. What's the width? What's the width of the rectangle? X minus 4, right? X minus 4. So isn't that length times width? And when I multiply those, what should I get as an answer? 21. Once you've created that, doesn't that look like a problem we saw on our quiz, on our tests, we've seen this problem before many, many, many times, right? That's what you're doing. You're getting to a point where, oh, I know how to do that. What's our first step going to be when we do something like this? What's our first step going to be when we see something like this? What's our first step going to be? Multiply, right? Distribute. Distribute a property, right? Distribute. X times x is x squared. X times negative 4 is negative 4x equals 21. What does that look like? Trinomial. It kind of looks like a trinomial, right? The only thing is I have two terms on the left, one term on the right. Let's get them together, right? So I'm going to move 21 over here. I can do that. How do I do that mathematically? What do I need to do? Subtract 21. Good. Minus 21 from both sides. That makes 0. Can I subtract 21 minus 4 to make negative 25? No. Yeah, right? They're not like terms, so I can't do that. So I'm just going to write them down. X squared minus 4x minus 21 equals 0. You guys are right. It was a trinomial. How do I solve that trinomial? We got steps for it, right? Needs to be in standard form. Done. What's the GCF? 1, right? Next step, ABC. So let's do ABC now. A is 1, B is negative 4, C is negative 21. So I'm looking for the two numbers that multiply to be negative 21 and add to be negative 4. What are the two numbers that multiply to be 21? Today, you'll find them. 7 and 3, right? 7 and 3, one of them has to be negative 7. Okay? So then we move to our parentheses, right? When that works, we can move directly to our parentheses. So we got a minus 7 and a positive 3, right? And then x and x. Then what did we do after that? What was the last step? Set them equal to 0, right? Some of you guys I was seeing on your test or your quiz, you can do that math in your head, right? You're like, oh, I know I'm going to get positive 7 and negative 3 as an answer. If you can skip that step, go for it. Okay? If that makes sense to you to skip that step, go for it. Okay? Because I've seen some of you guys can do that. If that doesn't make sense, then do this. Separate and solve. As we do this more and more, you're going to get better and better at it, which means you can skip steps. That's okay with me. I know because I look at your work and I can see that you're okay with that. Okay? Seven. Negative 3. Okay, so the thing about these problems is we have to answer the question. The question doesn't say solve for x. The question doesn't say factor completely. There's actually a question. What is the question for this problem? There's actually a question with an actual question mark here. So find the length in units, right? So what is the length going to be? The length is the long side, right? The length is the long side, let's see, this part right here, right? So what is the length of this rectangle going to be? 7, yeah, it's going to be 7. Is it going to be -3? Could there be two answers? Because I got -3 as an answer. That's right. I did the math right. -3 is an answer. But what's wrong with that in our question? Right? Can I measure 7 feet here? Okay. Can I measure -3 feet? There's no negatives on here, right? So I can't use the negative. So today, even though it's right, there's nothing wrong with it. I can't use that one. In real life, that doesn't mean anything to me. I can only use the 7. So we're going to answer the question. Remember, always answer that. We haven't answered the question yet. I haven't gotten full credit yet because I don't know what the answer is. How do I answer the question? I would just say length is 7 feet. Now I've answered the question. The question was, what's the length in units? Length is 7. What's the units? Feet. Okay. All right. Okay. So let's go to number 4 now. Lucy has a deck. Lucy has a deck that is 7 feet by 12 feet. It's a rectangle. Okay, so let's draw the picture. Draw the picture, 7 feet by 12 feet. Okay. She wants to increase each dimension. So dimensions are lengths and widths. So every length and every width, she wants to make longer. She wants to make longer so that the total area is 50% more than it was before. So what she wants to do is this. This is what she wants to do. That's the old deck. The new deck is going to look like this. In red. Okay. Here's my question though. How much does she want to increase her old deck by? 50% more, right? But here we go. In 50%, doesn't that mean half? Isn't 50% half? So how do I increase it by 50%? Not times 2, because that would be 200%. If she said increase it by 200%, that would be times 2. So how do I increase something by 50%? Because in my book, 50% means take half of it. So how would I increase something by 50%? Like if you were to get a 50% raise, is that a raise? 10% raise. Isn't 10% less? So you're taking away my money? Like what's going on? Like how do I increase by 50%? That's percents. I'm not going to tell you percents. You guys should know percents by now. How do I increase by 50%? So what is the new area going to be? That's my question. Well, what's the old area? How much is the old area? How much was the old area? And how much is the new area? Yep. How'd you get 84? Tell me, Bernardo. You're right. How'd you get 84?
I'm multiplying 12 and 17.
Good. Perfect. 84, what did we say? Feet, right? So feet squared, right? Good. That's the old, right? So what's the new going to be? It's going to increase by 50%. So shouldn't the number be bigger than 84? Because it said increase, right? That's what increase means. But how do we increase that number by 50%?
You divide it in half and then you add it.
There you go, right? Find half of the old. What was half of the old? So 84 divided by 2, right? And then you add it to what you already had. That's how you increase it by half. Okay? You take the old, and then you find 50% of the old. What's 50% of the old? How much is 50%? 42, right? And then you add that on top. That's how you increase by 50%. So if you get a 50%, if I make $10 an hour, or let's say I make $20 an hour, and your boss says, hey, I want to give you a 50% raise, how much money are you going to make? $30, right? That means, hey, I make $30 an hour now. That's what it means, okay? That's how you increase it, okay? And was that 126? So 126, that should be the new area. That should be the new area. Okay, so now we're starting to get somewhere. Okay, so how do I figure out what area is? How did I figure out what 84 was? Length times width, right? So now what I need to do is I need to go length times width of the new deck. The new deck. So what is the length of the new deck going to be, the red? There's going to be an X in there. Is it going to be bigger than 12 or smaller than 12? Bigger, right? So I need to add 12, right? How much am I adding to 12? Not 6. How much am I going to add to 12? Same thing with the width, right? It's not going to be 7 anymore. I'm going to add 7. What am I adding to both of them? Do we know what I'm adding to both of them? If I don't know, what do I do? There you go, right? If we don't know something, don't be afraid to put an X down. Okay? That's what we're solving for. I'm solving for the number I need to add. Okay? So what is the length times the width? So what is the length of the new rectangle? X plus 12. What is the width of the new rectangle? X plus 7, right? When I multiply those together, I'd better get 126. Okay? How do I multiply those together? Distribute, or most of you do, what do most of you use? Most of you use the box, yeah. There is a way to use distributive property, but most of you guys I know use the box, so I'll use the box. X plus 12, X plus 7. X squared plus 12x plus 7x plus 84. Combine like terms. X squared plus 19x plus 84. Move it back in. X squared plus 19x plus 84 equals 126. What does that look like? After I do that, what does that look like? A trinomial, right? It looks like a trinomial. So it looks like there is a trinomial over here, right? So I have to get this guy to equal 0. So I'm going to subtract 126 just like I did the last time. This time I can subtract it because there's like terms. 84 minus 126, those are like terms. I can subtract those. When I subtract those, I get negative 42. Trinomial. Finish the rest. What do you get? Finish the rest. You guys just took a test, a quiz, and you had to do this. You took a test before that, you had to do this. You took a quiz before that, and you had to do this. So I know you guys can solve trinomials. So do this right now. Tell me what you get as an answer. I'll give you a hint. You're going to get 2 answers. Okay? You're going to get 2 answers. Okay, so what are the 2 numbers that multiply to be negative 42 and add to be 19? One of them is a big number, one of them is a small number. 21 and 2. Yep, 21 and 2. Negative 2 has to be negative 2, right? So we're going to get positive 21 and negative 2. So we're going to get 2 answers, just like we always do. At least 2 answers. Sometimes we get 3, but today we're only going to get 2. Subtract 21 from both sides, add 2 to both sides. Okay. Answer the question. Have we answered the question? No, we have not answered the question. The question says, how much should she increase each dimension? How much should we add to 12? How much should we add to 7? How much should we add? How much should she add? Positive 2, yeah, positive 2. Because you can't add negative 21, right? We can't add negative 21 because I can't measure that. I don't have a measurement that does negatives. So we say, Lucy should add 2 feet to her length and widths. Lucy should add 2 feet to her lengths and widths. That's answering the question. Okay, that's what I mean by answering the question. Okay? All right, last one. As seen in the diagram, so this one they got a picture. They drew a picture for us. As seen in the diagram below, Noah is building a walkway with a width of X feet to go around a swimming pool that measures 13 by 6. So this is the swimming pool. I'm going to color code it on mine. This is the swimming pool in blue. It's already there. The swimming pool has already been built. But she wants to build a walkway around it. I don't know, wood or concrete, I'm not sure what, but she wants to build a walkway around it. Okay? So I'll label that in yellow. Okay? So there's 2 parts to this. The yellow and the blue. Okay? The pool is 13 feet by 6 feet. If the total area, so yellow and blue together, total area means yellow and blue together, will be 540 feet. So the total area is 540 feet squared. How wide should the walkway be? How did they come up with 540 feet squared? How did they come up with 540 feet? How did they come up with 540 feet? So not 13 times 6. 13 times 6 is actually going to be less than that. But you're right. Length times width, right? Length times width. So they did the big length times the big width. So what we got to do is figure out what this is and what this is, because that's going to equal 540. What is the length? How much of it do we know?
Use X.
So we're going to use X. We're definitely going to use X because some of it I don't know. So how long is it from here to here? From here to here, how long is it? X, keep going. It's not X, we know more than that. So I know some of it, I don't know. Some of it I do know, some of it I don't know. Which part do I know? I know the pool part, right? The pool part is 13. I know the pool part, right? The pool is 13, so that's part of it. So it's actually not going to be X because there's an X on one side and an X on the other, right? So how many X's do I have here? How many X's do I need to add up? 2 of them, right? So it's actually going to be 2X plus 13. Because I have it on both sides. The one I just did, it was only one side, right? It was only one side I needed to add. This one is 2 sides. Okay, so that's the length. 2X plus 13. What's the width? 2X plus 6, yep. 2X plus 6. Okay. Let's move this down. When I multiply those two together, I better get 540 as an answer. So what do I do? Distributive property or box, right? Just like I did before, just like you guys did before. So we get 4x squared plus 26x plus 12x. And the last one is 13 times 6, 8, 78. Combine like terms. 4x squared plus 38x plus 78. We can move that back. Looks like a trinomial again. What do we do? Subtract by 540. Yep, subtract by 540. Oops, that's not the one I want to cross out. What is it? 462? Thank you. 462. What's my next step? Yep, GCF, right? GCF, we can divide them. I think the biggest number is 2 that we can divide them by, yeah, because 38 doesn't work. So 2 is the GCF. I get 2x squared plus 19x, and then half is, I think, 231? Yeah, 231. So A is 2, B is 19, C is negative 231. So we go A times C. 2 times negative 231 is negative 461. Add up to be 19. There are two numbers. There are two numbers that multiply to be negative 461 and add to be 9. But I know if I were to give you this question on a test, that a lot of people would be stuck here and stop. They would be stuck here and they'd be like, raise their hand, and I can't help because it's a test. So let's say I'm one of those people. Some people can do this. Some of you guys I've seen, you guys are really good at this. But most get stuck here and stop. I can't do it. Well, yeah, you can. What do we do if we can't figure this out? What do we always do? Quadratic formula, right? So if you get stuck here, we have a formula, quadratic formula. Are there two numbers? Yes, it works. I did it last period because someone came up with the two numbers. But if we don't know the two numbers, instead of sitting there and just taking half credit, let's get full credit. Okay. A is 2. B is 19. C is negative 231. Multiply. Negative 19 plus or minus the square root of 19, 19 squared is 361 minus. Okay. 4 times 2 times negative 231. I have to put that in my calculator. 4 times 2 times negative 31. 4 times 2 times negative 231. Negative 1,848. Negative 1,848. Okay. So it's going to be addition, right? Yeah, because I had the minus and I already had the negative, right? So minus and negative makes addition. So you're going to end up adding them together. So we get negative 19 plus or minus the square root. And when we add them together, we get 2,209. Okay, 2,209. Okay. So negative 19 plus or minus, what's the square root of 2,209? I'll tell you, it's a whole number. It's 47, yeah. 47. It's not an I because it's a positive 2,209. So we're going to have two answers. I'm going to have negative 19 plus 47 divided by 4, and I'm going to have negative 19 minus 47 divided by 4. So what is negative 19 plus 47? I think, what is that, 28 divided by 4? Positive 7. Negative 19 minus 47, what is that, negative 66, I think. Divided by 4, when you divide that, you get negative 16.5. Have we answered the question? Nope. What's the question?
How wide should the walkway be?
How wide should the walkway be, right? How wide should the walkway be? What should those x's be? What is the width of all of those x's? What is it? 7. It's going to be 7. Not negative 16.5 because I can't measure negative 16.5. So we're going to put over here the widths should all be 7 feet wide. Okay, done. Okay. All done? Thanks, sir. Okay, so tape that into page 20, and we'll do some practice on Monday.